Alright, time for a review video on the nuclear material that you need to know. There's a few things about radiation, radioactivity, and fission and fusion that you're responsible for. First, let's talk about what radiation is. You hear the term regularly. You hear about nuclear power plants and the radiation they contain. You hear about nuclear weapons and their threats of radiation. It's important that we know what radiation is. Radiation is something that is emitted from or produced by an unstable nucleus. As that nucleus breaks down, it's going to produce either energy or particles. The energy we refer to as gamma radiation, the particles alpha and beta radiation. Those things that come out of the nucleus are called radiation. The breakdown itself is called nuclear decay. Nuclear decay is the spontaneous breakdown of an unstable nucleus. It falls apart on its own. Spontaneous means by itself. It happens in every atom with 84 or more protons. So polonium and above on the periodic table are radioactive elements. They are radioactive because their nuclei will break down. When they break down, they produce alpha, beta, or gamma radiation. These elements with their 84 or more protons have so much repulsion in the nucleus that the neutrons cannot hold it together. No matter how many extra neutrons it has, it will still fall apart. Nuclear decay can happen with elements that have less than 84 protons. This happens in certain unstable isotopes of those elements. Remember, an isotope is an atom that has a different atomic mass. A good example of this is the element carbon. Carbon, according to the periodic table, should have a mass of 12. And carbon with a mass of 12 is a stable element, a stable atom. Its nucleus will not break down. It will not have nuclear decay. But there is an isotope called carbon-14. Carbon-14 has a mass of 14. It has 2 extra neutrons in its nucleus. That is a radioactive isotope. That particular form of carbon will break down. Its nucleus will spontaneously fall apart. And when it does, it will produce radiation. Nuclear fission is one of the 2 types of nuclear reactions that you have to be familiar with. Fission is where we take a large, unstable nucleus and we hit it with a neutron. There's a lot of protons in there already. We're talking about one of these radioactive elements from the periodic table, the things over atomic number 84. There's already a lot of instability there. The nucleus already wants to fall apart. Now we hit it with a neutron and that pushes it over the edge. That causes the nucleus to split. When it splits, it produces new atoms. 2 smaller pieces. These new pieces will have lower atomic numbers and they will have smaller masses. They will be new elements. Produces a tremendous amount of energy in the process as well. Fusion is the other type of nuclear reaction. It's really the opposite. Where fission is splitting the nucleus, fusion is joining 2 nuclei together, fusing them together. In fusion, we take 2 small atoms, like hydrogen atoms, and we slam them together with a tremendous amount of force. They slam together with enough force to cause those nuclei to join together and become one new, larger atom. It takes a lot of heat for this to happen. For them to slam together with enough force, we have to get them really, really hot. Recall from the kinetic theory, the hotter something is, the faster the particles move. When we get them hot enough, they will move fast enough to slam together and fuse. Become one. Again, we're going to produce a new atom. Again, it's going to end up having a different atomic number and atomic mass. This time, it's the opposite. It's a higher atomic number. It is a higher atomic mass. I think it's best if we look at fission and fusion in terms of their similarities and differences. Compare and contrast the 2. So let's start with the comparing part, looking for the similarities between fission and fusion. First, both produce more energy than any chemical reaction. You can burn all the coal, the oil, the wood that you can find, and you still would not be able to produce as much energy as nuclear fission or fusion. Burning is just a chemical reaction. It can release a lot of energy, but nowhere near what fission and fusion are capable of. Both convert matter into energy. In most of the universe, matter is conserved. The amount of matter does not change. But in the cases of fission and fusion, matter disappears. It is turned into energy. On the sun, millions of tons of matter is being destroyed every second, converted into energy. That's why the sun produces so much energy. In nuclear power plants, matter is being converted to energy. That matter is literally being destroyed and turned into new energy for us to use. Both change the atomic number and masses of the atoms that they produce. They do it in opposite ways, though. Fission will reduce the atomic number, will reduce the atomic mass. Fusion will increase them. But they will produce new elements because of that change. The atomic number is changing, the number of protons is changing. We are making new elements in this process. The differences between fission and fusion: fission requires radioactive atoms or elements to do. Nuclear power plants require radioactive materials. Nuclear weapons require radioactive materials. Fission requires radiation. Fusion does not. In fusion, we're typically dealing with hydrogen atoms, making helium atoms. We don't have to worry about the radioactive fuels. We don't have to worry about radioactive waste products. Fusion produces more energy than fission. Fusion produces a lot more energy than fission. Think sun when you think fusion. Fusion harnesses the energy of the sun. Fission, much more than a chemical reaction, but much less than fusion. This is seen in the nuclear weapons. Early nuclear weapons were fission bombs, and as explosive as they were, they're nothing compared to the modern fusion bombs. Fusion bombs produce even more energy than the original nuclear weapons did. Again, the atomic numbers are going to change. We're going to make new elements, but we're going to do it in opposite ways. In fission, the atomic numbers and masses decrease. We're making smaller atoms with fewer protons, with less mass. In fusion, it's all going to increase. We're going to make a larger atom with a larger atomic number, with a larger atomic mass. So even though they're both making new elements, they're doing it in opposite ways. You do have to know the benefits and drawbacks of nuclear power, nuclear medicine, and nuclear weapons. Let's start with nuclear power, like the Catawba nuclear power plant. This should be in green. I don't know why I didn't have red. Advantages: there's a high yield of energy from a small amount of fuel. It doesn't take much nuclear fuel to produce a whole lot of energy. There's no greenhouse emissions. That means no carbon dioxide produced, no global warming. Reduces our dependence on fossil fuels. We don't have to use as much oil or gas when we switch over to nuclear. It can be used everywhere. Solar can only be used where there's sun. Wind can only be used where there's wind. Nuclear can be used pretty much everywhere. And there's plenty of fuel. We won't run out. We can, in fact, recycle the fuel that we have. Disadvantages: the big one, radioactive materials. Nuclear power plants use fission, and fission uses radioactive materials. The fuel is radioactive, the waste products are radioactive. They have to be treated with care and stored with care. We also worry about that radioactivity getting out of the power plant. If there were ever an emergency where radiation was released from the power plant, it could devastate the areas for literally hundreds of miles around that power plant, depending on how bad it was. Thermal pollution of lakes and streams. They have to use a lot of water to keep a nuclear power plant cool. So they often build artificial lakes and draw water out of those lakes to keep the power plant cool. They do pump warm water back into those bodies of water, which can cause thermal pollution, which leads to things like algae blooms and things like that. Terrorism. We worry about terrorism with nuclear power. We worry about terrorists, developing nuclear weapons, because literally you can take out a large portion of a city with a bomb the size of a suitcase, which makes it easy to deliver. We also worry about terrorists getting hold of these radioactive materials and making dirty bombs, where they spread radioactive material all over an area using a conventional explosive. It's technology only a few countries possess. Not many countries in the world have nuclear power, so it's not something that can be spread easily. Nuclear weapons. Advantages of nuclear weapons. Some say it prevents major wars. We haven't had a major war, like a world war, since nuclear weapons were produced. And some people credit the nuclear weapons for preventing that major global war. There's a reduced number of weapons. What 1,000 bombs used to do, one bomb can do now. So we don't have to have nearly as many weapons as we used to. Disadvantages. The disadvantages are pretty clear. Radiation. Even with the modern fusion bombs, we still have to use a small fission reaction to get the bomb to detonate. and that fission reaction produces a large amount of radiation. We also have to worry about storing and safely keeping all the radioactive materials around for these things. Terrorism, again, we worry about terrorists getting a hold of nuclear weapons. They can build a bomb the size of a suitcase that could take out half a city. We worry about that. And collateral damage, there's really no way to control a nuclear blast. It's going to take out a lot of civilian structures and cost a lot of civilian lives. Finally, nuclear medicine, the last thing you have to know advantages and disadvantages for. Advantages usually outweigh the disadvantages for this one. They're less invasive. Where we used to have to cut people open to see things, now we have nuclear tests that allow us to see and diagnose problems. We don't have to do as much surgery. Earlier diagnosis, we can see things now earlier than we used to before, and early diagnosis usually leads to a more successful treatment. More accurate diagnosis, we can see things clearer and better now, and so we're making more accurate diagnoses with these nuclear tests. They can see things other tests can't. They can see soft tissues, whereas X-rays could not. So again, it gives us more accurate diagnoses and earlier diagnosis as well. It's also one of the most effective treatments for cancer. Disadvantages of nuclear medicine: it's costly, the equipment, the tests are very expensive. We're exposing people to radiation when we do that, not only the people who are receiving the test, but the people who are giving the tests. We have to worry about the technicians at the hospitals being exposed to too much radiation, and we don't really know what the long-term effects of those are going to be, since it's a relatively new technology. Radioactive wastes. All those machines with the radioactive materials in it have radioactive wastes that have to be disposed of and stored. And it does damage some healthy tissue, especially when talking about treating cancers. It will damage some of the healthy tissue around the cancer cells, but usually the benefits outweigh the costs in that case. Honors class will not have a test on this. You will have a quiz, so make sure you do have everything. The rotational classes will have a test on it, so again, if you have any difficulties with it or questions about it, please post it on the wall.